All right, here is our guy on a bicycle. He's going forward at how many miles per hour?
7.3.
7.3 meters per second. He has a frontal area
of 0.45 meters squared.
0.45 meters squared, and he has a coefficient of friction of coefficient of 0.9. That's it. Remember that our force equation, or our drag force, is equal to 1/2 v squared times rho times a times CD.
That's actually easier to.
Okay.
What's D?
D? CD?
Yeah.
That's drag coefficient.
Oh, okay.
Normally they'll give it to you in the equations. And what are we looking for? The power output?
Yeah, what is the cyclist's power output while riding at a steady 7.3 meters per second?
Power. Remember that's going to be joules per second. And joules is the force times the distance per second. Do we have time for how long?
Nope. We don't.
Yeah.
Constant speed.
Do we have a... Oh, that's interesting. Do we have a distance that he travels?
Nope.
Awesome. This actually works. Good.
Okay.
Because look at this. We have force times a distance per second. What does that look like? Distance per second?
Velocity.
Okay.
Cool. That's your power. Hey, that actually reminds me. That is power.
Yeah. That's,
Yeah. Okay. I remember that from dynamics. I remember it being really easy, and I didn't remember it till after I had to go through all that work.
so how do we find force?
That's the drag.
Oh.
So your power is equal to 1/2 v cubed times rho. What's that rho? The rho of the person, the density of the person, of the bicycle.
Density of air.
Times the frontal area times the coefficient of drag. Good job. Don't forget the
So
little
drag
fringe tail.
coefficient is 0.9. Cross-sectional area is 0.45.
Wait, is
Row of air. Do we have row of air? Are we given velocity?
Well, rho of air is normally is just 1 kilogram per meter cubed.
like that or like 1.5?
1.24. That's it. 1.24 kilograms per meter cubed.
And then our velocity we're given as 7.3 meters per second.
What was the units on air?
It's kilogram per meter cubed. So it's how much weight per volume.
Okay.
So we're okay. Our velocity is 0.3 meters per second. Look, I think they will cancel out. I'm not sure.
Yeah. They should. Well, they won't. They shouldn't cancel out. It should be.
Kilograms per second.
I should give us the units of. Did you cube the velocity?
Mm-mm.
Meters cubed per second cubed times kilogram per meter
Squared.
cubed.
Cubed.
Rho is cubed
Cubed, right.
times meter squared.
So we should get kilograms meters squared per second.
Yeah, because it's cubed. Yeah, so we should get kilogram meter cubed per second. Per second cubed.
Is that work? Is that power?
Let's see, let's look at it, because that doesn't look like anything we've seen before, right? So let's see, your work is gonna be a force times a distance over second. Does that make sense?
Mm-hmm.
We got that? So let's see, kilogram times meter per second squared, Newton, 1 force, times a meter, all over second. Oh, that's squared, sorry. Start canceling stuff out. Or I guess in this case we don't cancel, but m times m,
That'd be squared.
and then that over that. You flip and multiply, so it's gonna be 1 over s
So cute.
cubed. Turns out that's what we got.
Cool.
Yeah, keep the units. The units will help you guys a lot to solve problems.
So power is kilograms per meter squared per second.
Mm-hmm. Yeah.
Okay. What was the answer that you typed in your
I
calculator?
got 97.68.
All right. So that is enough to power 1.5 light bulbs. A 60-watt light bulb. That's what watt is. It's
Or
How many?
one 100-watt light bulb.
yeah.
Okay.